Gaya. All right, so good morning, everyone. Good morning, programmers. Welcome to our session today. So for today, we're going to discuss about tree structures. All right, so in since the beginning of our discussion, we talk about the idea of data structures and algorithms, and we have been discussing about the abstract data type now. So how important is doing ADTs, and then starting with the creating our own ADT, as well as we have also tried at least no a little bit of how to go kato akong gitudlo sa inyo about time and space complexity, no, or the algorithm complexity is it's about it's actually ComSci thing, no. It's what makes a ComSci unique as a in terms of what they call this one, because that's how they are made, that's how they are built. No, they have to know, they have to create an algorithm that is really mathematically inclined. Yan. So that is why katong nitudlo na ako sa inyo na time and space complexity, there's still more on it. So in fact, after sa data structures and algorithms, napa na siya algorithm complexity or design and analysis of algorithm. So lahi po ng systems analysis and design, no? Or algorithm complexity, or depende kung DSA, basta design of algorithm complexity siya na discussion. Focus on evaluating certain algorithm in which kung asa ang faster compared to others. Now, ang focus na to for data structures is how we get to arrange our data, maybe in linear banner ba, and how a few algorithms are actually does the process of arranging the data. So after which we discuss about ADT, because that's the foundation of making an algorithm or creating an algorithm. So we started with sorting algorithm, and we have learned a few algorithm techniques, and eventually, hopefully, we are able to evaluate which one is faster compared to others. Okay, though they are just the same, but again, in a way that the other is parang advantage if we're gonna be using this algorithm compared to others. Parang we are able to learn that because we have understood that based on the evidently, no, if if we get to parang program them, that's the time we are able to experience a certain algorithm that let's say it's a sorting algorithm that with other that bubble sort is really slow. Okay, then here comes we discuss about linear data structures. We have a stack algorithm, which is last in first out, no, algorithm, which has been used by many different computer applications and even some games. So queue algorithms used by banking system, used by sprinter pooling, and other similar applications. And then we have also discussed about other techniques in uh, data what the cryptography. No, we are able to encrypt a certain message and then decrypt it so that we know what's the hidden meaning or hidden message after it is encrypted, and which has been used by several applications like privacy, masking, and all other for security reasons or security purposes. Okay, now we have also FIFO in linear data structures, so which is first in, first out, and then after which we implemented them using an array-based implementation. The only limitation with the array-based stack and queue array-based implementation is that it has its limitation in terms of storing the data. Okay, so that is why we discuss about linked lists, now in which we store as much as data as we can, and as we store them, you can store at as we can store in many different locations, like at the beginning, at the in the middle, or at the end of the linked list. So and then it is dynamic data structures, no? Dynamics data structures in a way that you can store as much as data as you can. And then there are certain algorithms that like traversal, adding a certain value at the beginning, at the end, and at the in the middle. And then the though compared to stack and queue algorithm, because I mean stack and queue algorithm, it's of course these are list algorithms, and they serve its purpose. Kumbaga, that's why their algorithm is like that. It's because nasa sila yung purpose on why it's created as that. Okay? But the disadvantage lang is it is implemented in an array-based implementation. Now, pwede nato siya implement using linked list algorithm. So, si stack ug si queue, pwede na siya ma-linked list. Okay? So, basically, si linked list kasi is an algorithm at the same time a structure. Okay? Okay, so it's a separate structure where it's a different structure where compared to array, limited lang na itong ma-store na data. Si linked list really, no, as many as data as you can, pwede nimo ma-store. So si linked list has three types. We have singly linked list, doubly linked list, and circular linked list. So when we talk about singly linked list, you only have list or one list or node, and then the node contains data and then the pointer that points or link that points to the other link, making it a list or making it becomes linked together. So that's singly linked list. Sa doubly linked list naman is kanya akong i-discuss later on sa inyo, which is daghan siya applications, no? Mga three structures. And then circular linked list is ang data structuring niya is from the beginning up to the excuse me. Excuse me. Gi-off ang light. Hello. Ngit-ngit. Ngit-ngit ko, dili. Awag, gi-off. Ilila ang light. Wait lang ha. Namina mo?
Yes, sir.
Okay. Sige.
Yes, sir.
Gi-off nila ang light eh. Alright. I'm back. Eh, basi mura taog baluga dito makita. Sige. Asa na gani ko? Yon, linked list. Then, circular linked list. Circular linked list naman is about a ang iyang movement would be the list at the beginning and then mag-create siya list, then next linked list, next linked list, and then pag up to the end, mubalik siya going to the first list. So, mura siya og sa billboard gani na kung naay 3 ads sa billboard, pag first ad, then second ad, then third ad, pag abot sa third ad, mo loop siya going back to first ad. So inana ang idea sa circular linked list. So now we're going to focus on the doubly linked list, which is it is implemented in a tree. So tree is actually a linear data structures. So linear data structures. So to give you an idea about what is that tree, actually tree, when you talk about tree, we are already surrounded with trees in our file systems. Example, this one is an example of a trees. Now, these ones are actually nodes. Actually, kung sa programming, tawag na to is tree structure. Okay? So, this one is a node, a tree. This is a tree, a tree, a tree. So, all these are trees. And then each tree composed of nodes na siya. And then, ang nodes sa tree, it has three components. Naa siya data, which is, let's say, quick access. And then, naa siya two link na left link o right link. So meaning to say naa siya duha ka link na going towards another link. So which is instead of isa lang ang imuha ang node sa like linked list is isa ka data at the same time isa ka pointer sa trees na kay duha ka pointers. Na kay pointer to the left and pointer to the right. So later I'm gonna show you kung saan siya. So example, we have here this linked list as a node, this quick access as a tree. When we are going to expand it, naatay makita na mga nodes or kumbaga directories there. So we can consider this as the children of this parang node. So let's have another one. Let's say this PC. So this PC is a tree. Okay? It forms hierarchical data structure, which is this is the root, kumbaga root node or the parent. And then if you're going to expand this, you will see there the children of this directory. And every child of this, okay, naapod siya is subdirectories. So let's say for an instance, we have bootcamp C, na po siya another children belongs to it, no, containing in it. So and every child naapod siya is sarili niyang mga children. So that's the formation of tree. That's how data structures tree is or ana siya. Now, so now that you know na gi-apply na siya dra as in fact naani siya sa Visual Basic. Kung pilion niyo dito tree, makita to ninyo makahimo mo ginaani na structure. Dali lang. The good thing about there sa tree dito sa Visual Basic kay imo lang siyang i-drag and then maghimo lang kag inaani tapos himo-himo lang kag mga butang-butangan lang nimo mga names every child niya. So now, as a data structure, what is it? Okay? Tree is an inverted ang representation sa tree sa programming is an inverted tree. Meaning to say, ang normal tree sa real world kay ang root na asa sa bottom. Pero then ang branches niya nasa going upwards. Sa data structure sa programming, ang iyahang root kay nasa taas while ang iyang branches nasa baba, going downwards. So that's tree. Okay? So example, you have here this one. So as you can see, you have here the tree. Okay, delete sa nato. So you have here the nodes A, B, C, D, E, F, G, H, I, J, K. So we can say that the A is the root and it's the parent node and it has two children, B and C. And the children B and C has also children. Okay, so we have D, E, F for B, G and H for C. And then for E naman, na siya ay J na children and then G na ay K na child. While here, it seems like it is a tree, but it is not a tree. Why? It is not a tree because according to our definition, it is the remaining nodes are partitioned into n disjointed set of nodes in which each of it is a tree. So meaning to say there is the children should be directly connected to its parent. All right. So kung napansin mo dre ang second figure na to, you have the A as a child, as a parent or the root, and then you have the B, C, and D as children. So okay pa siya dre na part. Pero pag abot sa B, nasa children na G, H, I, pero nasa edge na going towards E, which is the child of C, no, which is a child of C. Probably kung sa real world pa ni, pwede na kani si B o si C nagkarelasyon, okay? Nagkarelasyon sa og na anak nila si E. Okay? So yeah, that's something na it is not allowed in a tree. Okay? So dapat walay child si ang isa ka node na dili directly connected sa iya or child siya with other nodes like si C is, I mean, C, E, and F are children of C, therefore it cannot be a children of B anymore because it is already a child of C. Okay? So we call this as graph algorithm. So lahi ko ni siya na algorithm. While sa tree, again, it should be leaning towards, or ang edge niya should be towards its children or a children from coming from one direct connection or edge from parent. Okay. Question. Nasabtan?
Yes, sir.
Okay, good.
Yes, sir.
So now, let's talk about the terminologies before we move on about trees or tree algorithms. So to start with, I have already introduced to you some of the terms. But this time we're going to uh, discuss them more. No? Okay, so consider this as a tree. This is a general tree. So when we talk about general tree, okay, any tree with more than two children. Okay, more than two children. Meaning to say, pwede daghan ihang children. So, like si 22 na ay children na 18, 10, and 26. And si 18 na ay children na 16, 15, and 19. So, pwede pa na siya mga lain, no? Kaupat, kalima, basta kay connected siya with a single node. Okay? Dili pwede duha iyang parents. Basta isa lang iyang parent. Alright? That's general tree. Now, let's talk about this node. So, by the way, kung may yung tag-linked list, recall that sa linked list, okay, we refer a node which composed of the data and then the pointer, no? The pointer or the link that points to the other node. So, matawag na to siyang node pag grabe na hiwi po ani no. So matawag na to siyang node pag nasa data and link. So basically sa linked list, mao ni diri ang data, okay? And then this is the link or the pointer, and then mo link ta siya or mo point ta siya going to the other node, which is another node na po siya data, and then you have here the link. If yeah, diba? Based sa akong discussion, kato kung I hope inyo itong na watch. So you have here another data and then another link. So ayan, then you can store data in the you can store node in the middle, you can store node at the first, something like that. But that's at least how you will understand node na nasa data and link. Now, that's simply linked list. Pero sa binary, sa trees, okay, sa tree, particularly sa binary tree, which we are going to discuss it later. So it will be something like this. So a tree composed of a node, okay, this instead of there are only two elements in it, there will be three. Okay. Okay. Now we have here the left link, okay, or the left pointer, and then we have the right pointer, and then you have the data. Now the link pointer will be pointing to the left node, of course, and then it will create another node. You will create another link pointer here or pointer, and then the data, of course, which is the value, and then the right node. Similarly, that's the same thing you do. That's the same thing what it does in the right node. Okay, so which is mauni siya. So I data and then I write, and then I left. So this is what happens here. This is the data, 22, 26, 28, and as a node, na siya link pointing to another pointer. So what's the take? Anong kailangan mag-inani siya? So basically, general tree is believed to be hierarchical tree. Hierarchical tree or non-linear tree. Okay? Or sorry, non-linear data structure. Anong naa? Because the very essence why naa general tree is is to improve, okay, searching process or retrieval. Para papaspason ang searching process or retrieval. Why? Nganong kailangan siya papaspasan? Of course, no? It's very important for your program to offer faster searching of records. Okay? So who wouldn't like that? Of course, we all like that. Now, kasi ang the idea sa linked list is idea kasi sa linked list is when you do traversal and when you're going to look for a value, let's say na kay list of, let's say mao ni ang ika 1,000, and then this is the first list. Sorry. And this is the second list, third list, and along with it, na in between, na siya, basta na ang ika 500 na list, and then 1,000. And if you're going to say, let's look for the 955th na list. If you're going to look for 955th list, believe me or not, ang linked list is, it has to traverse from the very beginning to the next list, next list, next list, next list in a sequential manner. Okay? Before it is going to say na 955 or ika 955th data is actually found. Okay, that's the disadvantage. Though okay siya, pero that's the something na we don't like to happen. Okay? Now, this is the worst case scenario. If, let's say, we want to look for 1,500 data. And let's say we don't have 1,500 data in our list because let's say we only have 1,000. So it has to visit from the beginning of the list until the 1,000, ika 1,000 na list, and only to find out, only to say that 1,500 is actually not there. So that's something that's something really dramatic, no? So dramatic in a sense na it's really tiresome, it's really tedious, not tedious, but it's really time consuming, and knowing na wala man di ay. So the very reason why trees are there, it's because to eradicate that kind of problem or scenario. So example, I have here my file directory system here. And then if I say, I can find my movies under Satoshi D. Okay. Kung linked list ka, you'll need to visit each node or each list here or each node. That's what you do because that's how your computer is tasked to do it. Do you follow?
Yes, sir.
Yes,
Yes,
sir.
sir.
Pero kung mag-trita, okay, pero kung mag-trita, 3, delete 4, delete 5, ito, pero kung mag-trita, it's going to, it's now going to visit directly the node, particularly here. Okay? Na, if you say, oh, which one particularly ang imong ginalook na value, asa dapit na node, so, kasi nasa node na Satoshi D. And it's not easy to really to create this kind of course, now we can say na easy lang siya because we have the graphical user interface. Siyempre, we have here the UI now, the anti-computers. But of course, the way it is programmed, it's not as easy as like that. Okay? So, of course, para maging wise enough ang algorithm, they created a tree algorithm which directly visits a node, particularly kung asa siya na node or tree, and then you look for directly going to a certain folder. Okay? So at least it is not going to visit the entire trees or nodes. So naay part na ma-visit pero at least dili tanan. So that's the idea of trees. But of course, kita kay UI man nato ang makita nato siya directly. But again, okay, the way these ones are programmed, okay, behind this is really a tree algorithm. So that's what we are going to focus on our discussions. Now, we don't do that for now, but that's what we are going to do later. Okay, so first is let's have familiarize the terminologies. Okay, now that I have built a parang an impression, no, that why trees are really important in data structures, nga nung kailangan nato siya ma-learn na okay na naman si stack, na naman si queue, na si linked list. Okay? So we don't settle on one algorithm. If possible, we have to look for a better algorithm. Pwede na to i-apply si linked list, sa stack, si queue. But then again, we can create another algorithm and improve them. And this is what it takes, like knowing what tree is. So now let's discuss about some terminologies of trees. So a tree must always have a root. Okay. So the root is the parent of all nodes. So I've told you nodes ni siya, node, node, node. Everything that you see here are nodes. Okay, with left and right pointers. So one tree must have one root. Dapat imong tree isa lang ka root. So kung napansin niyo dire, if this PC is a tree, na siya root na this PC. If desktop is a tree, na siya no, root na desktop. If Satoshi D, Bootcamp C, Google Drive G are nodes, then therefore, mao ni siya ang mga nodes nato or root node nato. So going back here, so root, there must be one root in our tree. Dili siya pwede na daghan tag roots. Okay? So, now, the root is, of course, natay ginatawag na link. Okay? The connecting link to each children is what we call edge. Okay? We have the left edge and the right edge. So, each node is connected with edges. Okay? Dili tong kanta sa luha, ha? So, dili po na katong edad. Edge. Okay? So, we have the edge of this parent 18 going to its children 16, going to child 15, and another child 19. So again, we call this as edge. So the link, okay, the link that connects directly the parent and the child is what we call the edge. Yan. Okay, now next term or next terminology in since tree is hierarchical tree, okay, so we have this what we call parent, okay, parent nodes. So what is parent node? Parent node is any nodes having an edge going downwards, and then there are nodes there. So meaning parent siya because it has children. Basically, it's like that. So as you can see, we have here the parents 18. So if we're going to actually give the sets or what are the parents, we could have here 22 is actually a parent, but it's a root node. It's a root parent that can be considered as a parent. So we have here the 18 is a parent, 26 is a parent. What else? 20, 29. Okay. 10 cannot be considered as a parent because it doesn't have children. Okay. So these are parents. So parents 18, 26, 29, as well as 22. These are called parents. But if we say, what is the parent of, okay, what is the parent of, let's say, 19 or node 19? Of course, you can say directly that the parent of node 19 is actually 18. Okay, do you follow? Very good.
Yes,
Simple.
sir.
Okay, good. Now, let's talk about children. So, obviously, children are nodes attached or has an edge directly from its parent. So, you have here children, like children are any nodes except for root, because again, these are all children. So meaning these are all children of 22. So mga children na siya. Only that, maingon tag when we say what is the direct child or children of 22? Only 18, 10, and 26. Do you follow? So children of 22 are 18, 10, and 26.
6.
Similarly, kung 18 has children which are
16.
16, very good. What else?
15. 19.
Very good. Okay. How about 10? What's the child of 10?
Wala siya children, sir.
Okay. The child of 15 is null, meaning it doesn't have, it's a null set. Wala siya child. 25 doesn't have any child. 28, 33, and all other nodes there. Okay. So that's parent and parent children. Okay. Let's have another term. Let's talk about ancestor. Okay, and then let's have here descendants of the son. Joke lang. Descendants. Okay, when we talk about ancestors or ancestor, this is a node which is parang a node that is connected by the edges going upward. So these are actually like para mas dali, these are your grandparents, these are your parents and grandparents or your mother, grandmother. Okay? So if we say what's the ancestor of 18? What's the ancestor sa 18?
22, sir.
Very good. 22. Ancestor of 10.
22, sir.
22. Ancestor of 26.
22. 22, sir.
Okay. Ancestor of 16.
8.
18.
18.
8 and
22.
22. Ayan, that's good. Okay. Ancestor of 16 are 18 and 22 because 16 is a child of 18 and 18 is a child of 22. Therefore, 16 is 16 is a child of parent 18 wherein grandparent niya si 22 because anak siyang mama na anak sa iyang lola. Meaning, iyahan na siyang there is relationship between 22 and 16. We call them as, of course, grandparent and grandchild.
Grandchild.
Okay. And these are called grandchildren of 22. Okay, nakuha? Okay.
Yes.
So now, ang tawag na tong grandchildren, tawag na to are, muna siya ang descendants. So, children and guys, son no grand, dito, grandchildren. Okay? So, if we say what are the descendants of 22? Descendants of 22 are unsa?
Lahat sila, sir.
28,
28.
16,
15,
19,
25,
23.
Actually, para dali, para dali na siya, may dili all, no? So, nasaon man nyo na, except for 22. All nodes except for 22. Ayan. So, all nodes except for 22. So, pag may unta, grandparent of 33.
Si 26, sir.
29, 26, 20,
Ancestor of 23.
20 na, 23.
33.
29, 26, 22.
29, 26,
29,
and
26,
22.
22.
Okay. Ano lang, simple ka, di ba? Simple, no? Simple kayo ang concept. Okay. So that's ancestor and descendants. Now, let's have sige, this one. We have this also term like siblings. Obviously, siblings are your masama ng siblings kung sa ano pa, real world.
Brothers and sisters.
These are your brothers and sisters. Okay? So, if we say siblings of 18, 10
10
and
and
26. Okay, siblings of 16.
15 and
15 and
15,
19.
19. Happil ba sila 25 and 29?
Dili.
isa na.
Dili.
It's
Okay?
related.
So, dili
Yes.
siya related because they have different parents. So, 18, 10, and 26 are siblings because they are connected directly to its ancestor or parent na 22. 22. So, we have also here these are 16, nodes 16, 15, and 19 are all children because they are connected directly. They have the edge directly from its parent, which is 18. Ayan. So, siblings yan siya. Okay, next.
Cousin.
Cousin. Cousin. Walay cousin. Kung magbot-bota, sige, pwede. No? Si tao sa graph ay cousin, pero di wala. Okay. Okay. Pwede man mag-cousin si, pwede cousin si, kani si 25 o si 19, cousin niya siya kay ang ilang mama o ilang parent kay 18 and 26 anak man ni 22. So, pwede, sa bagay. Okay. So, anyway, but we call them as naana siya other term, mga successor and predecessor. Or, basically, when we talk about successor, kinsa man ang successor, actually mauna imuhang mga descendants. Predecessor mo na imong ancestors. So, pero naatay ginatawag na successor node or predecessor node. And we have to follow a certain algorithm to determine that. So, sa kanana. Now, we have this called na leaf. Okay? Napo tayo gitawag na internal node. Okay, leaf is a node with no children. So, unsa man ang node na walay child dira?
10.
10, sir. 10.
10, 18, 15, 19,
Kadaghan?
20,
10 ra ang leaf single.
20.
Si 10 lang, sir.
Sure? Unsa na
Ilan?
yun?
Si, ano, sir? 16, 15, 19, si 28, o si
25, 29, ug 33.
Wala. Leaves. These are leaves. Mao na siya mga leaf. They are nodes with no children. So, mao na siya mga leaves. So, walay child. So, I don't know if some books called it as external nodes. Yeah, probably like that. So, natay ginatawag na internal node or terminal node. Correct me if I'm wrong. Upload yan ako ni sa YouTube do kasi mali ko, pero sige. I-ratom lang nato siya pohon if mali ko. So, internal node or terminal node. So, when we talk about internal node, these are nodes with at least one. So, with at least one child, meaning basta na ay child or one, sorry, wala na kay plural. At least one child except for root. So, asa daw pasabot anak, unsa may mga internal nodes dira? Sige daw. They are nodes with at least one child except for root.
26.
20.
18. 18 is an internal node. Si 18 na ba siya question, is 18 a root? Root ba si 18? Dili.
No, sir.
Sir, ang 22 ano
Dili.
lang?
Okay. Alright. Now, dili siya root, of course. Na ba siya child?
Tatlo, sir.
Na, sir.
Okay. Naa siya tulo. So, at least one meaning sobra pa siya. So, we call this as internal node. How about si 10? Dili siya root.
Wala, sir.
Hindi.
Wala siya root, sir.
Dili siya root. Dili siya root, pero wala siya ay child.
Wala siya.
Okay. 26.
Child.
Dili, sir.
Internal node siya, dili.
Dili.
gyapon, sir.
Okay. Very good.
25.
Internal node gyapon kay na siya child na 25, yung child na 29. How about si 29? Internal node ba siya?
Yes, sir.
Okay,
Yes, sir.
internal node yapon kay naa siya children 28 of 33. So, kung dili siya internal node, dili, therefore, lives siya or live. Nakuha? Okay? Pero ang
Yes, sir.
internal node again ha is any parent except for root. Walay labot ang root. Nakuha, class?
Yes, sir.
Sige, now let's proceed. Napay daghan. So, natay level, natay height, depth, and then naatay height. Okay. So, sa level, depth, and height, it depends on the implementation kung array-based siya or linked list based. So, pwede man gud array-based atong implementation. But usually, ang ato ang trees will start with level 0. Okay? So, therefore, kaning root nato is level 0. So, kaning 18 going to 10 until 26 are all level
1.
1. Okay? So, tawag na to as level 1 nodes. So, mayroon ka, what are the level 1 nodes? Kaning 18, 10, and 26. Kaning si 16, 15, 19, 25, and 29 are level 2
Level 2.
nodes. O, mura games lang, no? O, di ba mura og sa kanang elimination round sa mga nagdula go, di ba inaani ang style? Okay?
Ranking,
And rankings. And then we have this part right here, which is the deepest
Level
node.
3.
Okay, mo ni siyang deepest node. This is level 3. Okay? Now, what is height? Ang height kay pwede ka mag-start with 0, pwede ka mag-start with 1. Okay? So, pwede ang counting nimo 1, 2, 3. Okay? 1, 2, 3, 4. So, ana, 1, 2, 3, 4. Okay? So, meaning, level, mura ko siya nag-anog level, but 1, 2, pwede siya 0, paadulong 3, 1, 2, 3. Pwede ana. Okay? So, height is actually, let's say, ang height is 0, same with level. So, 0, 1, 2, and 3. Okay? So, we have here the height of 3. Ang depth naman is height plus 1. Okay? Wala, wait, tama ba po? Double check na to ha. Check na to. Kaya nakalimot yung picture. Height. Yan, height is yan, tama. Okay, tama po. Depth is height plus 1. Pero naay uban na books na ang height is 0 or 1. Basta careful mo na height is either 0 or 1. Depende sa ilahang paggamit. Kaya naay uban manggod na tree na array ang implementation. Na ako'y uban na tree na linked list implementation. Of course, sa linked list, mawala ang idea of index. So, dili siya mag-start with 0. Pero bisan pa mag-array siya, napoy uban na maggamit direct, dili siya mag-store of value sa index 0, directly sila mag-store sa index 1. So that's why depende siya sa programmer's way. Okay? Pero let's follow the 0 kasi 'di ba bisan mag-linked list ta, bisan mag-array ta, naghihapon ang idea of indexing. So we start with 0. So depth is height plus 1. So if depth is height plus 1, therefore atong depth, ang kalulumon sa tuang 3 is pila? 4. Because 3 plus 1 is actually 4. As easy as that. Okay? So, path naman. Ang path is the path is the edge of the edge of each node that are connected with each other. So, kung mayroon ko, what is or how much path, pila may path sa 16 to 10. So, we have 1, 2, and then 3. So, therefore, the path of path 16 to 10 is actually, pila to? 2, 3. It's actually 3. So, kung yung path 16 to 20, 25, 1, 2, 3, 4. So, ang path 16 to 25 is actually 4. Tama ba? 1, 2, 3, 4. Pag maingon ko the path of 16 to, let's say 16 to 16 to, okay, 9 times na walay path going to path of 26 to 25, 26, 29, 33 to 19. Pwede ba na may path? Wala. So 25, 26, 29, 30 to 19. Pwede ba na may path?
Hindi siya
So,
katabok sa 19.
Okay, very good. Dili siya pwede. So there's no path from 25, 26, 29, 33 to 19. Dili na siya allowed. Ang path lang is katulang connected na mga edges. Okay? So that's for path sa pagani. So, okay. So this is ang tawag nato ani dire, pag naa siya dire na part, this is what we call left subtree. Obviously, ang tawag nato ani is right subtree. So, sir, namay sa center. Okay, general tree magunta. So, general tree, sige, tawagan lang ito na siya center tree. Pero later on, we're going to discuss about, kasi when we talk about trees, there are actually different types of trees. Naatay na ito na binary trees, binary search tree, AVL trees, decision trees, expression trees, red black trees, and there are actually a lot of trees no na ato ang ano pa later on. So these are just some of the definitions para makasurvive, not makasurvive but at least makarelate ta sa mga topics nato in the succeeding weeks. So again, that's the definition of tree. By the way, when we say natang ginatawag na forest, naadjud no? So forest is a collection of trees. So yan, pag naa kay daghang trees, different trees, so we call them as forest. Okay? All right. So this time let's talk about binary trees. Okay. So binary tree is a special type of tree. Na hindi mo ka PowerPoint. Oh. Wait lang ha. So, umanata sa general tree, dili jud ma PowerPoint, sige na lang. F5 daw. Okay, pasensya, live di siya. Asa naman akong slideshow dire. Slideshow, play from the beginning. Okay, let's talk about binary trees. So general tree is a tree with that has or that can have multiple children. Pwede siya 2 or more children. Si binary tree naman is up to 2 lang ihang child. So it can have at least 1 child or at most 2 children. So dili pwede more than that. Kaya siya gitawag og binary. Diba? Sa binary digits, zeros and ones lang. So duha lang jud, either wala siya anak or naa siya'y anak pero duha lang taman. Okay? So 0 or 2, 0, 1 or 2 lang taman. So pwede walay anak, pwede ra naa basta 2 lang siya. So that's binary trees. So as you can see here, as a tree is a binary tree if all or in every node has at most 2 children. So in the first tree, this is not considered as binary tree because node 1 has 3 children. So this is not considered as binary tree. This is considered as general tree. While the other one or the other figure is actually a tree or a binary tree. Ayan. So what's the property of binary tree? So property of binary trees, okay, nakuha kong alas 5 na, please lang. Ay, naka-alarm man di ay. So we have binary trees have a few interesting properties when they are perfect. So, unsa din ang perfect tree? Okay, later on, I'm gonna show you unsa ng perfect binary tree. So, we'll talk about complete binary tree, full binary tree, perfect binary tree, balanced tree, degenerate tree, skewed tree, pathological tree, and all those trees. No, ito siya mga other terms and types of binary tree. So, property number 1 of a binary tree, the number of total nodes of each level double as you move down the tree. So, baya siya binary, mura siya og kanang sa mga sige na scheme sa kanang mga sana pyramiding, no? Di ba na binary something that every time there's a one level which is the root, and then if mga anak tong root og another two children. Okay, so that's 1 times 2, that's another, you have another 2 nodes. And then katong imuhang 2 ka children, every level, kung mga anak na po itong node, times 2 na po, you have now 4. And then katong na po imuhang next node, going from there is 4 times 2. Pag mga anak na po, tumahimo na siyang 8. So, kaya that's the property of a binary tree, no? I mean, that's a unique property of a binary tree. Okay, next is property number 2, the number of nodes on the last level is equal to the sum of the number of nodes on all other levels plus 1. So what does it means? That ang last level, kung sa tong ang last level is actually the result of the sum of the number of nodes on all other levels plus 1. Okay, so that's how binary tree. Basta perfect lang siya. So perfect meaning all nodes are filled with 2 children. Dili siya pwede na isa lang ang child sa isa ka node or isa na left run or right. So perfect siya means ang iyang nodes kay duha ka buok every level. Nakuha class?
Yes, sir.
Na ma-visualize ninyo, imagine ninyo ba na root, parent, tapos mga anak siya duha, and then ang duha na pud nimo ka child or children, mga anak na pud duha, isa-isa sila mga anak ug tagduha, isa-isa mga anak, basta tagduha ilang anak, then next level na pud na mga anak na pud duha, mag-double siya, and then which is all levels ato yang sum ato the last level is equal to the sum of the number of nodes on all other levels plus 1. So that's when our binary tree is perfect. Okay, so these are some of the binary tree related definitions. The children of any node in the binary tree are ordered into left and child, right child. So pag sa binary tree, insertion can be left, node, a root, left, right, node, node, left, right, then left, right, left, right, left, right, left, right. So that's it. A node can have a left and a right child, and a left child only, a left child only, or a right child only, or no children at all. So pwede ang node, ang isa ka node, pwede na ay right child, pwede walay left, pwede na po na ay left, walay right, or pwede walay child, or nothing at all. Okay? So, ayun, no? The tree made up of a left child, which is a node of X, and all its descendant is called the left subtree of X, which we discussed earlier during sa general trees. And right subtrees are defined similarly, which are, okay, number 1, full binary trees. So what do we mean by full binary trees? When we talk about full binary trees, these trees are only allowed to have either either no children or 2 children at all, but it cannot have 1 children or one child. So ang child niya either duha or wala dapat. So dili siya pwede na isa lang ihang child every node. Okay, do you follow? No, wait.
Yes, sir.
Isa
Yes,
ng
sir.
sig chat. Nice sig chat, wala. So, ingna ko kung ay question kay dili ko maka ano. So, that's
Sir.
full by yes.
So kana siya na kanang dira sir sa example sir kay dili na siya perfect na ano na binary kay wala may na may walay kuan child na.
Yes. Mahimo siyang perfect pag kani siya na siya a node na siya another node, all levels are filled with nodes.
Okay po sir.
Okay, basta ayaw lang tong send nodes. Ayaw, joke lang. Okay? Sige. Now, ito na ng aw-aw, no? Pag crisp na mo, kay para way aw-aw. So, again, full binary tree na ay anak na duha dapat pero dili pwede isa lang. Pwede, or nothing or wala di anak at all. So, nakuha, that's full binary tree. Ang complete binary tree naman, pwede siya na ay anak. Okay, ako na ang Bisayaon para dali, diretso, para dulot. Pwede siya na ay anak, pero dapat sa left iyang anak. Dili pwede sa right. And then, dapat all levels. So, I'm gonna repeat. A binary tree whereby if the height is D, example D, no? And all levels except possibly level D are completely full, meaning it's filled with nodes. If the bottom level is incomplete, then it has all nodes to the left side. So meaning to say, bahalag incomplete ang next level sa node, pero dapat left child ang iyahang, nasa left child ang iyahang child. So, if ever na si 5 na sa right child, dili siya matawag as complete binary tree. So, complete binary tree is ready to be what? Is something that is ready na mahimong full binary tree. Nakuha?
Yes sir.
Yes, sir.
Okay. So, ana lang, no? So, example, pag na ako dire, na ako'y left sub tree dire, na ako'y node dire, matawag ba na ako siya as complete binary tree?
Yes sir kay naman siya sa ano.
Yes, sir. Naman siya sa left side.
So, what happened here? What happened here?
Ay, di.
Okay. Dili siya because all levels.
Ay,
Tama?
tama dahil, sir.
Oh.
Oh, yes, sir.
All levels. So dapat kani siya na node dapat, na ani node dapat before pa siya magka nodes. Nakuha? Bahalag
Okay.
sa left lang siya. Okay? Making it na mahimo siyang complete binary trees. Okay? So that is the difference between complete and binary trees. So let's try. Let's check. So what is this node? Tree. Complete or full binary tree? Alas 6 na.
Yes sir.
Wait lang, attendance sa dito.
Full.
Full sir kay
FOOL.
Full.
So,
Kung complete siya is
Foolish heart. Sana all.
the full.
2543. Sige, o sama na. Good. Good afternoon lang po nito ha.
Full.
This is good afternoon sa 2543. Naka-record ba rin eh. This is unsa?
Full.
Full binary,
Full binary.
full binary tree. Dili siya complete binary tree. Why?
Wala children ang nasa.
Wala
Or children ang 22, sir.
Which
So,
is
dapat-
22 note.
Dapat ang 22 filled with nodes pa ni siya bago
Yes,
si 36. Good. Okay, very good. Let's check.
Complete.
Complete.
Complete, sir.
Centrum complete. Very good. Okay, complete na siya. Walay duda kay na siya, all levels are filled with nodes, pero na isa ka level na dili siya filled with 2 nodes, pero na siya left child. Tama?
Yes.
Yes.
Okay, next.
Yes, sir.
Complete.
This is
Complete,
Full
sir.
Complete.
complete.
Ay,
Full.
Yes, sir. If na may level.
Na may isa ay
Na
full
may-
sir full. Na isa na wala ano.
Ang
Okay.
16 ug 19, sir, kay wala siya og 25 wala ano.
Okay,
Children.
ayan. Ang level nila is kani dapat. So meaning kaning levels dire filled di siya with 2 nodes. So dapat kay nagka 2 nodes siya, dapat kani siya na siya 2 nodes here, na 2 nodes here, na 2 nodes here. So dili siya matawag as complete binary tree. Pero we can call this as Is it full binary tree?
Full binary tree.
Okay, why? Kasi all nodes has 2 children. Nakuha?
Yes, sir.
Yes, sir.
Basta
Yes, sir.
gani duha ka buk children niya regardless of tanan nodes, tanan level walay na ano basta filled with 2 nodes or bahalag walay node, walay ang uban level walay walay child basta kay at di ba ang idea sa full binary tree is no nodes at all or 2 nodes dapat. So mo nang full binary tree. And this is complete binary tree? No, because every level should be filled with nodes before ka maka-fill with nodes here. Okay? Let's check. How about this one?
Complete.
Full or complete?
Complete, sir.
Full, sir, kasi yung isang level ay kulang.
Complete.
Ha? Complete?
Full.
Full, sir.
Okay? So, full binary tree? No. Kasi nanay node na isa lang.
Kulang isa ka, child.
Bago lang kay kulang isa nga, isa lang ka child. Okay? Isa lang iyang child. Dapat duha or wala. Tama? Complete ba
Yes,
siya?
sir. Yes.
Yes, sir.
Are you sure?
Hindi rin, sir.
Naman sa left side, sir.
Naman sa left side ang katong si 16 good sir. Ayahang anak niya na 15 nasa sa left side.
Pero naay level na walay
29. Ang
Naay
29.
level, pero naay level na walay filled with 2 nodes sa same level. Ni diretso siya anak sa 6 sa 15. Therefore, this one is not complete. Ano na pa check? Not complete nor full binary tree. Why? Kasi naay level na si 29 dili filled with binary with nodes. Dili siya pwede kasi dapat kani siya is anak pa ni siya diri.
29 and 20.
So, general tree na siya, sir.
Binary tree yapon. Pero
Binary
dili
tree.
lang siya full, dili lang siya complete binary tree.
And 24.
Binary tree lang siya. Normal binary
Ah.
tree.
Okay.
Okay? Sige. Variations man siya of binary trees. So, kung si 15 na siya dire, matawag na to siya as complete. Tama? Kung dire siya ang 15. Nakuha niyo yung difference karon?
Pero ang 24, sir, wala man siya
Walay.
wala man siya nodes.
Mo ibalhin nato ni siya dire.
24
Okay, so 15. Tapos kung magka-node man siya, dapat na po dire. And next na po ma-fill in bago pa si 16 kung puno na si 29. So dire na po ka sa 16.
So kailangan sir ma-fill ang level 1 na, sir.
Yes. Diba? That's the
Bago
definition.
mo proceed sa level 2 na, sir.
Dapat all levels daw. All levels are filled with nodes. Bahala ang nodes isalay child basta nasa left. Pero dapat all levels are completely filled. Kaya siya complete. All levels are completely filled. Only that if the last node or the deepest node or the last level is not completely filled but naa siya left node. Nakuha wala?
Kuha, sir.
So, ano man mo, nasipyat man. Pero sige, anato ha. So,
Okay,
again, but at least we tried now na inana ang full binary tree and complete tree. So, how about this one? Complete ni siya, no?
Dili
Hindi.
Dili.
Dili mo na ko.
Dapat sa left.
Murag dili sir.
Okay, wala may
Yung 11, sir, di pa nanganak.
Because
dapat sa left na.
ang levels na left sa ang 11 na level o 23 wala pay anak ni diretso siya nanganak sa 23. Tama?
Yes,
Yes,
sir.
sir.
So
Yes,
dapat una sa siya dapat una sa siya magkaanak bago magkaanak si 23 anak ba? Bago matawag siya as complete.
Manganak sa ang 11.
Manganak sa si 11. Manganak sa duha sa 11 bago manganak si 23.
Wala man
Okay.
anak.
Anong bitawan ng anak? So baog. Sana all. Okay. Full binary tree ba siya?
Yes, sir.
Dili, sir.
Dili, sir.
Binary lang.
Ay,
Kulang isa ka kuan child. Dapat 0
Yes,
or
sir.
2.
okay.
Either
Mahimo
1,
siyang
2, or
full.
none.
Maghimo siyang full basta walay anak si 23 or naa siya anak pero sa right. Nakuha.
Yes, sir.
Yes, sir.
Ayan, sige,
2
lalibog
or
kay libog
none
pa
of
jud
them.
gamay. Sige, sige na lang. Let's proceed. Oh, perfect. What's a perfect binary tree? So this is what I told you earlier. So ang root na ay anak na left-hand child, lingaw kay no ang trees no? Na ay lingaw kay ang concept. So na siya child, duha ka children, and then 2 more children nanganak na pug another children, so naga-double iyahang nodes. So a binary tree is a perfect binary tree in which all internal nodes have 2 children and all leaves are at the same level. So example of a perfect binary tree. So parehaan ni si 0 node nanganak og 1 and 2. Okay? And then si 1 and 2 nanganak na pud og another node. So 1 times 2, 2. 2 times 2, 4 na pud yang anak. Kung manganak na pud ni sila tanan, 4 times 2 mahimo ng 8. 8 times 2, 16. So inana si perfect binary tree. Okay? So pwede ko ingon na if how many, sige daw, how many nodes are there in perfect binary tree if I have level 5. So nako'y level nako sa level 5. Pila ka buok ang nodes sa binary trees? Sige daw.
Five times.
No, iha pa. So kung manganak ni siya, this is level 0, 1, 2, level 3, na madungagan na siya pila? 8, di ba? So 8, pila na ni? 8 plus 4, 12, plus 2, 16, we have 17. Okay? Next, level 4, pila na anak sa imong nodes? Mahimo ng 16. Pila ganitong last na tong ano dire? So, hello, are you still there?
Yes, sir.
Pila, so 16 plus pila yung nodes na dapat ano niya? So this is kung magkaanak ni silang upat tag duha-duha para kay perfect man. So magkaanak ni siya og 8 ka nodes. Awa ha.
8.
Asa naman po? Manganak ni siya og 8 ka nodes. So, ako i-ano sa inyo ha. Anak ko na to ni. Okay, manganak ni siya nodes. Manganak ni siya nodes, manganak ni nodes, manganak ni nodes, 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 nodes. So 4, di ba? Double daw iyahang size. 4 times 2 equals 8. So 1, 2, 3, 4, 5, 6, 7, 8. So pag manganak na po siya na next level, all nodes will have 2 children times 2, 16 na po na iyang ano. So mo double iyahang size sa imuhang node. Yan. Wala, naglisod na ko sulat. Basta double na siya ha. Hala, basta inana na siya.
28, then 16, then 32.
Okay?
Then
So 16 ni siya, kani 8, kani 4, kani 2, kani 1. So 1 times 2 equals to 4. Times 2 equals to 8. 8 times 2 it is to 16. So pila na ni ka level? Level 0,
0,
level
1,
1,
1,
of
2,
course 2,
2, 3,
3, 4.
4.
Okay. Kung manganak na po di siya, di na nako iano, basta manganak ni siya, pilay anak aning level 5.
32, sir.
32. Ay,
Okay, 32 nodes. Okay? So now, pila ka buok nodes, tanan, all in all, pag nanak ko sa level 5, i-plus lang di mo ni si 32, 16, 8.
4.
So 32 plus 16, that is 48,
8.
56, 60, 63. Therefore, you have 63 nodes sa level 5 when your tree is perfect. All right. Tapos, according sa ano is actually ang iyang calculation ana is ang calculation ana is 32 times 2 pila?
64.
Okay, 32 times 2 is 64. Okay? And then,
Minus
tama
1.
ba? 32 times 2 minus 1, that is the total nodes. That is your total nodes. Para mas dali ang calculation. Oh. Anak siya. Sige. So, nakuha. That's perfect. Binary tree. Okay? So, di na lang ako i-PowerPoint. Ibalik. O, sige. Tama ba ang calculation na to? Masin mali. Okay na. Sige. Masin mali ha. I-upload yan na to sa YouTube ni. Patay ta. Okay, next. Patay yung teacher. Okay, full binary tree, complete binary tree. So, full binary tree, duha yung anak. Pwede wala, pero dapat wala dyan siya anak di ay. Pwede wala, pero kung naaman siya, dapat duha. Anak ha, pwede wala, pero kung naaman siya anak, dapat duha. Sa complete, pwede siya isa lang iyang anak, pero dapat sa left. Dapat all levels. Sa perfect, of course, makawag na to siya perfect pag perfect, yun kayo siya. Nga pilo-piloon mo siya, perfect yun iyang measurement. So because all nodes are filled with nodes. All level in the node are filled with nodes. Yeah. So, this one, erase na to ni kay okay, natay ginatawag na balanced binary tree. The height of the left and right subtree of any node differ by not more than 1. So, ayan, let's reserve this one. Pero let's discuss first the degenerate tree or pathological tree and skewed binary tree. So, ang degenerate tree is node is every internal node has only one child, meaning isa lang yun ang child. Actually, pati si skewed binary tree. Kani si degenerate tree o skewed binary tree, it's a node with only one child. However, ang difference nila is that kung maingon ta og degenerate tree in ani yang ang structure niya. Na siya yung node, yang anak, mga anak na po siya pero sa right, then mga anak na po siya para sa left, then mga anak siya sa left, then mga anak siya sa right. So tawag na to is degenerate binary tree or pathological binary tree. Ang skewed binary tree is all nodes have only either one child or no child. Pero, ang iyang child should be leaning towards in one direction or going towards one direction. So, mahimo siyang skewed binary tree if ang node nimo is like this. So, nakay in-aninas formation and then napod kay another tree. So, let's say ana. Okay. So, this is left skewed. Of course, this is right skewed. So, going to the left, going to the right. Ang pathological kay ana, balik. Sana alternate na left, na right, or left, right. Okay? Ayan. And then, so that is the example of pathological and left skewed and right skewed binary tree. Okay, so to review, we have here full binary tree. Okay, we have complete binary tree. So duha yan children. Sa complete is isa basta kay nasa left, bahala dili bahala dili full basta naa sa left. And then degenerate, perfect, and balance tree. Okay? So ang balance tree ang pinakalisod i-determine. So let's reserve that for another discussion. Okay, so this time, ano akong giingon sa inyo ha ganina, sa binary tree, a binary tree is it's a doubly linked list which has nodes that composed of data, pointer to left child and pointer to right child. So ang formation niya would be like this. So data left and right, data left and right, data left and right. So it points to null, meaning there's no node in it. So in aniyahang formation. So the root, the children, then there's another children in the future. So that's binary tree. Ako sa naman. I just have to finish this like. Okay, so benefits of binary tree. the search operation of binary tree is faster, no? Mas faster kasi I told you earlier na you don't have to visit or traverse from one node to another, to every node in a sequential manner because it's binary. Probably there's a big probability na you don't have to visit the left subtree or the right subtree or the other way around. You only are going to visit either sa right subtree or going to the left subtree. Okay, which is we can apply that in a certain tree algorithm. Okay, now we have only two traversals are enough to provide the elements in sorted order. So we have this what we call depth first traversal and breadth first traversal. So in binary trees, it will be easier to pick up a maximum and minimum elements. But this is for binary search tree, I guess. And then conversion of postfix and prefix, which we actually discussed during stack algorithm. It would be easier for us to convert prefix to postfix using binary trees. Okay, and graph traversal are also uses binary trees. So graph traversal are a different is another algorithm, no? Lahi ko na siya na algorithm, pero it follows the traversal techniques of a binary tree. So meaning to say, though another algorithm si graph, pero it still follows the idea of traversal that is used by binary tree. Okay, so applications used in many search applications where data is constantly entering or probably leaving. So meaning insertion, deletion, ayan, meaning constant siya na nag-insert kag value or delete of value as a workflow for composing digital image for visual effects, used in almost every high bandwidth router for storing router tables, and it's also used in wireless networking and memory allocation. So allocating memory or data resources to our memory, and it is also used in data compression. And there's actually a lot more, no? In fact, gamit siya sa mga pyramiding, sa scheme, sa kanana ng mga scheme gani, no? Ginagamit siya for doing such para mas easily matrace ang imuhang sa tawag na imuhang earnings, no? Kanagay na, di ba? Mao ni imuhang structure sa imong tree, and then mao ni imong it would be easier for you to keep track of your earnings based on your structure on that binary scheme. Yeah, I don't know sa kanang sa mga say tawag ana nila kanang yung front row inana ba kanang pyramiding na sa binary scheme. Okay, so let's now have the traversal techniques of binary trees. So sa traversal, when we talk about traversal is a technique where each node is visited from left to right. Pero sa linked list, i-visit niya from the beginning up to the end. So there are two types of traversal. We have breadth first traversal, and then we have depth first traversal. Sa breadth first traversal, we only use level order traversal. But sa depth first traversal, we have two techniques there. We have pre-order traversal, in order, and post-order traversal. So let's do this together. Sige. Kaya pa? Kaya pa, no?
Kaya na, sir.
Kayahon. Okay, kani. Kailangan na ito ano-ani kay medyo libog-libog yan siyang gamay. Okay, sige. So, let's say we have a tree, a binary tree. Hindi ko kabalo mo drawing, no? Sige lang, pagbigyan na. So this is what tree? Binary, complete or full?
Complete.
Okay, very good. Okay, so let's start with traversal. Traversal techniques. Number 1, breadth first traversal, level order. So level order traversal is by level. Kabalo naman tayo sa level, di ba? Level 1, level 0, level 1, level 2, level 3. So let's say we have numbers here. So 23, 24, 15, 18, 10, 100, 16, and let's say 35. So these are your nodes in your binary trees. So sa level order traversal, it is going to visit all levels and then node left, right. So upon visiting it, every time you visit, you'll have to follow the algorithm technique. In level order, it will be every level must be visited every node in that level must be visited in order of node left, right. Okay, so starting with number 1, 23. Next is 24. Then next is 15. So as easy as that, ano lang. Okay, 10, 100. 100 ba na? Yeah, and 16. And then 35. So that is level order. Okay, very simple. So node left, right, left, right, left, right, left. Okay. Now, let's have depth first traversal. So number 1 is you have in order. Okay. So in order traversal suggested that you visit first the left child. Okay. Followed by the node, left node, followed by the node or the parent node, and then next is the right node. So left, parent, and right. Pwede po siya LPR, no? Depende sa imo. If gamito nimo basta left is of course left node. Okay. And then the node is actually the parent node. Okay, other books ko instead of node ang gamiton last P. And then R is obviously right node. So in order, you visit the left first, then print, then node, and then right. So how do you visit the traverse this node? So this is how you do it. This is how you do it. First is you visit the left node, which is unsay left node dire.
Si
Unsay
24,
24, 18.
18 og si
left, pinaka-left. Unsay pinaka-left sa last level.
25.
Okay,
35, sir.
35. So first you print and visit and print 35 because that's the left, followed by next. So say sunod,
18.
node. Okay. Since 18 is a node and therefore it must be visited and then printed. Okay.
18,
Next.
24.
Question. Si 18 ba na ay right node? Wala.
Wala, sir.
Wala.
Wala. So mo skip ka, dili na ka mo visit dito. Okay? It's a waste of time. Actually, null na siya. Ang kabutang ani tanan dire, actually nakabutang ani dire mga null na ni siya. Null meaning wala ni sulod null. Okay, kay linked list man basta mga null na siya, meaning dili na i-visit basta null. Okay, kasi loop man atong gamiton dire or recursion. So 18, then unsay next na nabasa niya?
24.
Left node, so 24. Okay. Then, unsay iyang sunod basahon? Right. Okay,
10,
visit
sir.
niya ang right, which is 10. Okay, next niya, so left sub 3 na ni siya, humana ang left, mo balik na pud ka siya sa unsay sunod. Ma-consider na ni siya as left, unsay sunod i-visit.
Si 100, sir.
23, sir.
Okay, 23 because that is a node. So anin na siya left node right. So if i-follow nato siya, na humani mo visit si 35, 18, 24 and 10, left na ni siya and then unsay node niya?
23.
23.
23.
So i-visit sa niya ang 23. Upon visiting 23, na siya node sa right child, wala. Wala.
Ang 23 sir na
Oh, Sa iyang node,
15.
15.
15. Aron, question. I-print na niya si 15, dili.
Dili, sir. 100 mo.
Dili, sir. LNR man, so 100 then.
Okay. So since 15 is a node, and based sa to ang definition kay naa siya ay based sa iyang structure naa siya left and right, and then as suggested by in order dapat kung node siya with left and right dapat mubalik ka sa
Left, sir.
left node and right. Therefore, instead of i-print nimo si 15, i-visit lang nimo si 15, pero mo traverse ka to its left node, which is that's the time you will print its node. And then followed by unsa
15.
may sunod node, which is 15. And then next node is the last node, which is the right
16.
which is 16. Okay, pwede na to ni siya i-check. Okay, check na to, left. Okay, 15. Ang node kay 23. So, di man siya balance, di man siya perfect binary tree, mao nang dili kay siya pantay ang iyahang ano. Pero kung perfect binary tree ni pantay jud ni makita nimo na ang left, tapos si pinaka node na nasa center. Tapos 16 ang pinaka right. So, left node and then right. Nakuha? Nakuha, class?
Libog.
Diba? So, left node, walay right. Adto ka diretso sa node. So, left man ni siya. Anak class, left node, so walay right. Therefore, mana ka sa cycle na LNR. Pag humani mo sa LNR, balik na po ka sa LNR. Pag humani mo sa LNR, balik na po ka sa LNR. Pag humani mo sa LNR, balik na po ka sa LNR. Pero make sure na if makita gani mo na based sa iyahang traversal, if node gani siya, then na siya left and right, mo balik ka sa traversal which is left node right. Assuming kaning sa 23 pag node right yani ka sa 15, since 15 has two children, therefore balik siya og LNR. So mahiwa na po siya ang LNR. So anak siya. So ang idea niya is LNR, 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 LNR. Anak siya, left node right. Sige, try nato sa pre-order. Okay, pre-order is node left, right. So, that's pre-order. So, node left, right. So, sa ibuhaton, visit niya ang pinaka-node. So, pinaka-node niya is 23. So, unsay sunod i-visit?
24.
24.
4.
So, si 24, nana po siya ay pag-visit. Next niyang i-visit
15.
kay left. I-visit niya si left, tama?
Yes.
Oh.
Pero
Yes, sir.
pag-visit niya sa left, kay nana po siya yung node, nanana po siya yung left, therefore, hantod, ato siya sa pinaka-last na level. Nakuha? So, node, left, pero node siya, nanay left, then node, nanay left. Yung sa sunod,
10, sir.
right. Okay, which is ang pinaka-right nila among, o diba left ni tanan, right na pud ka. Which is ang right na pud niya is 10. Okay, now, this is left sub 3. Humana ang tanan left. Ikan sa node and then left, adto na pud ka sa right. So in the right sub 3, pagka-traverse niya, na ay 15 na ay children na 116. So we have 15, 116. Therefore, what will happen? Ang iyang is 15, ano lang, 15, 100, and then 16. Check. Node. Okay. left, asamang left na to. 35. And then right,
16.
16. So node, left, right. So check lang na ha. I'm not saying that ano na, pero that's how I actually check na I would say na tama. Pero of course, kani siya, iwan ako nang i-check dire na node left right pa na siya. But again, it would be really taas na process. But that's how I actually check my traversal kung tama siya. So meaning dako ang chance na tama na siya. But it does not guarantee na tama ni ang dire in between. Okay, last last traversal is post-order traversal. So ang post-order traversal is left, right, node. So, kamo daw, left, ang sa'yo una,
35.
35.
right, followed by
18.
18.
18, nga naman, kay walay right si 35,
80.
walay 35, si 18. Next,
24.
24.
Are you sure?
Ay,
10.
si 10 di ay kay
10.
right.
Okay, right. And then, 20.
23.
4.
Ay, 24.
24.
Okay. Next is, kinsa?
100.
100 ay.
Okay, 100. Kay si 100, kay pag ato niya sa right child, right sub 3, na ay 15, pero
Gian lang.
na siya yung left node, which is 100. Sunod,
16.
16.
16.
Sunod,
15.
sunod, 20.
23.
3.
So 35. Okay, left, pinaka-left. 35, yes, tama. Right, which is left, right. So probably ang ano na to na ma-consider as ang right kay 18, 24 pero nasi 100. So right, and then you have the node which is 23. Ano siya? Okay? So pwede po na si 10 ang right basta kay in between ana are parang that's the right ano in the right subject. Okay, so let's have another example para makuha jud. So another example ta. Pero this time kamo akong pahay mo. Sige daw. Example lang niya, this is not a test or a quiz. So what I would like you to do is inyo pag ano mo sa inyo hadra and then i-post niyo sa atuang diri sa kaning message ibutang niyo dra inyong answers. Okay. Okay. So I'm now going to start. Tarungon sa nako. Wait lang. Kay pangit kayo. Don't like it. Kay perfectionist di ano yung teacher. Joke lang. So, pretas tunga-tunga. Perfect circle. Oh, wow. Nice kayo akong pagka-circle. Oh, I like it. Wow. Wow. Mura og pandesal. Ay, usa ba ni? Mura pan, no? Patay, sir. Unsa man na, sir? Sige. Para ma-challenge mo. Okay, sige. This is, let's say, 18, 13, 14, 15, 16, 17, 18, 19, 20, 21, and nabay nagbalik, wala. 33. Ayan, sige. So, I'm going to give you, wait lang. Ano sa nato kung sa unahon yung ano. So, level order, uh, in order, post order, wait. Butangin level ha, post order and then pre-order. Okay? Sige. So, ang ano na to ani is ibutang lang dire, self-check lang. Ano na to? No, ayaw lang mo pangupya, ayaw ni kopya ang answer sa inyong classmate. Basta ibutang niyo dire, answer niyo dire inyo based on katong sa sequence. Okay? Based ani. All right? So, that's it. Sige, I'll give you ay di maulay no. This one. So, I'll give you time. Wait lang. Ato sa ning i-stop ang recording para we'll have another set of recording kay medyo taas na kayo ni siya.